So in class today we'll do 2 and 4 together, and then I'll assign 3 and 5, and then on Thursday I'll do 3 and 5, and then we'll take the test. So that's sort of the roadmap.
What about 1 and 6? Are those the ones we're throwing out?
So I think if we cover 4 of them really well, I think we'll say you can throw out 1 and 6.
Okay.
You can omit 1 and 6. We'll just say that from the get-go. If you feel like you need more practice and want to, the solutions are posted with the 1 and 6 solution posted as well. So they're out there if you want to pursue them. Before we start with number 2, again, look at the years on this. 2018, 2015, 2014, 2013, 2010, 2009. So not every year, but pretty frequently, this accumulating rates of change. Let's just back up and talk big picture for a minute. If you take the integral of a rate, you know what? Let's back up even one more than that. If you take the integral of w prime, you get w. And so this was, well, if we put a and b on there.
Yeah. W minus W.
Yeah. And that has been a question multiple times on AP test, free response and multiple choice, where they give you all sorts of crazy information about W, and then they ask for this, and people are like, oh my gosh, this is crazy. And you're like, no, think about what they're asking you. It's just W at time B minus W at time A. Here's a bigger picture way to say that. If you integrate a rate, you get the change in the amount. Integrate a rate, you get the change in the amount. That's kind of the main thing for today. So they're going to give you a rate, and they're going to call it, they probably won't even call it W prime. They'll call it W or R or F or G, but they're going to say that it's a rate. And so you know if you'll integrate that, you'll get the change in the amount. All right, so let's look at number 2. Again, I want these on separate notebook paper, nice and neat. We'll still turn all of these in on Monday, so nice, you're ready. Number 2. The rate at which rainwater flows into a drain pipe is modeled by the function R. Okay, so already be careful. This is a rate where R equals 20 sine T squared over 35 feet cubed per hour. This is definitely going to be a calculator problem because there's no way they would have you do anything by hand with sine of T squared over 35. The rate at which rainwater flows into a drain pipe. So that's rain into a pipe is modeled by that function, where T is between 0 and 8. The pipe is partially blocked, allowing water to drain out the other end of the pipe at a rate modeled by, so another rate, but this one's drain. So I don't know if they mean R for rain and D for drain. Oh, that rhymes. But one of them's going in, one of them's going out. So we'd be careful about that. Negative 0.04 T cubed plus 0.4 T squared plus 0.96 T. So that's the rate that it's flowing out. So already I'm thinking one's a positive, one's a negative, right? So one's going into, that's positive, one's flowing out of, that's a negative. Also from 0 to 8, there are 30 cubic feet of water in the pipe at time 0.
That's a point.
So that's a point. Yeah, water in the pipe. I mean, we could call that P. P of 0 is 30. So be careful about what they've given us. They gave us a rate in and a rate out and an amount to start with. So already I'm thinking if I integrate the rate, I'll get the change in the amount, and I know how much to start it with, so I can figure out how much is there. Let's see exactly what they ask here. Part A, how many cubic feet of rainwater flow into the pipe during the 8-hour time interval? How much rain into the pipe on 0 to 8? So I know the rate at which rain is flowing into the pipe. That's R. But I want to know how much flows into the pipe. So what do I do with R? I'm pretty sure D isn't part of this problem because I only want what's going in.
Take the integral.
Integral. So I will integrate R. Because, yeah, the integral of a rate will give me an amount or a change in amount. What about my limits?
0 to 8.
0 to 8. That'll tell me how much water flowed into the pipe from 0 to 8. And so sometimes the calculator ones are easy because, hold on, let's get this set up. I'm going to put in, all right, if you're using one of my calculators, change it back to radians, change it back to functions even, because we were in parametrics. And I think it's worthwhile to put them in Y1 and Y2 just because there's a lot coming to this problem. So you don't have to tell the grader you're doing this, but it might be helpful. That way if you, not really mess up, but if you write Y1 and Y2 later, you'll be okay because you've told them that Y1 is R and Y2 is D. Probably more importantly, it's helpful for you to keep it straight. So Y1, 20 sine x squared over 35. Y2, negative 0.04x cubed plus 0.4x squared plus 0.96x. Okay. Now I need to double and triple check those because I'm about to use them a bunch of times. 20 sine of x squared over 35 negative 0.04x cubed plus 0.4x squared plus 0.96x. Okay. So I got them in there. I probably won't have to type them again. That's my guess. So this is really all the work I'll need to show. If I realize that I can integrate the rate to get the amount, then math 9, 0 to 8, y1 dx, and let's let the calculator do its thing. Always 3 decimals, 76.570.
Yay.
Probably units.
Feet.
Well, it says how many cubic feet, so it didn't ask about units, but I'm going to go ahead and put it on there.
Just to be safe.
Yeah, you'd be okay without it because it specifically said how many cubic feet. If your answer is 76.57, then you answered the question. Still remember arguing with my Algebra 2 teacher about that. When the question on the test said how many feet, blah, 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 and I only wrote 13, and she took off a point for units, and I said,
What?
You asked me how many feet, I told you.
Did she give you the
Did you
point
win or
back?
lose?
I lost.
What?
I lost the
So
argument.
you're saying that teachers are wrong a lot of the time?
Sometimes.
I could tell you stories of my middle school math teacher who was wrong a lot of the time, but that's a story for another day. I've been wrong plenty. Last time was back in 2017, but
Majorly wrong? Or?
All right, part A is done.
That's the other Astros cheated.
Part B.
The Astros did not cheat.
Yeah, they did.
Is the amount of water in the pipe increasing or decreasing at time 3? Water in pipe increasing or decreasing at time equals 3. I realize I'm just rewriting the question, but it's helping me think about this answer. Is the amount of the water in the pipe increasing or decreasing at time equals 3?
Well, how do we, the slope, right?
The amount.
Is the amount increasing or decreasing? So that would be the slope of the water in the pipe.
Yeah,
Right.
which means we have to, something.
But, so we're talking about
So the slope of the amount?
yes,
So wouldn't that just be what it is?
that would be just R and D.
Yeah.
Yes. So it's worded kind of funny, and you get to thinking about, whoa, I need to find the slope. But R is the slope of the amount, or at least the amount incoming.
So is D.
D is the amount outgoing.
But we add those together?
Well, one's incoming and one's outgoing, so I think I need R of 3 minus D of 3.
Well,
That's,
I'm pretty sure you knew what I meant.
so let's do Y1 of 3. And again, you don't have to show anything other than R1 of 3 minus D of 3. And you could use Y1 and Y2 there since you've already explained what Y1 and Y2 are. Units helps here too. Both of those are feet cubed per minute. So that is a change.
I thought it was per hour.
Is it per hour? It is per hour. But it's
Reset
per
that.
time. I reset the clock. I messed up.
What?
Reset that.
2023.
I was wrong.
It's a good 6-year run. So what does that mean? If R3 minus D3 is negative,
It's
Decreasing
outbound.
faster than
it's-
it's increasing.
right, there's more going out than coming in.
Can we just say decreasing and leave it at that?
Well, you definitely need to say decreasing. So amount is decreasing because that's what they asked.
Alright.
Now, I don't know that you need to say more going out than going in. R3 minus D3 kind of says that. That's just me thinking out loud. Part C. At what time is the amount of water in the pipe a minimum?
Uh-oh. So when do they have zeros?
Okay, so don't do R and D yet. Just tell me, when do we have a minimum?
When P changes from a negative slope to a positive slope.
So when when P, that's the amount of water in the pipe, changes slope negative to positive. So that means when P prime changes negative to positive,
Which is both D and R.
and P prime, in fact, maybe that would have helped to make this statement earlier, P prime is R minus D. Does that make sense?
Yeah.
R minus D is the combined rate of change for the amount of water in the pipe. We've introduced another variable, so you better be careful. You're free to do that, but you need to tell them what it is. And I sort of said that with P of 0, but I need to say that water in the pipe is, I'm going to call that P. You are more than welcome to introduce variables as long as you explain what they are. So I want to know when P prime changes negative to positive. So I want to know when R minus D changes negative to positive. So how could I do that?
D is bigger to when integral.
There's an
I
even
don't
better
know.
way than that.
Look at the graph.
Look at the graph. The graph of what?
R and D?
Even better than that.
Oh, look at the
Just look at the graph of R minus D.
Ah.
Right? Like, why make this stuff more complicated? Like, let's do a graph of R minus D. So y1 minus R2, or D, excuse me, R minus D, which is y1 minus y2. I need to be careful here. Right now I've got all three graphs on the same graph. That would look kind of funny.
Yeah.
So I'm going to
Unhighlight
turn
the top
off
two.
the other two
Oh.
so I know which one I'm looking at. My window is all messed up because of pre-cal.
Just hit zoom 6.
I'm going 0 to 8 is what I'm looking for my X values.
Scale 100. Jeez.
I have no idea what my Y values would be. But I just want to know when it changes negative to positive, so I guess it doesn't really matter as long as I can see the x-axis.
This one's dead completely.
There we go. There's a negative to positive.
This one's dead completely.
Okay, just leave it there. So it changes negative to positive right there. Second calc, intersection. Oh, first curve, enter. There's only one curve I'm looking at. Oh, I didn't want intersection. That's why I messed that up. Second calc. 0. Left bound.
0.
Right bound. Guess. So at time equals 3.272 hours. All right, part D. Pipe can hold 50 cubic feet of water before overflowing.
Okay.
For T greater than 8, water continues to flow into and out of the pipe at the given rates until the pipe begins to overflow. Write but do not solve
Ooh, I love that.
an equation involving one or more integrals that give the time W when the pipe will begin to overflow.
Okay.
Okay. So we already said what P is. We want P to be greater than 50. I don't know that that would get you any points, but at least we're on the way. That's what we're looking for, is when is the water in the pipe greater than 50? Let's see. So now I need some expressions for P.
Yeah.
Wait a minute. If P prime is R minus D, then to get to P,
We take the integral.
so let's integrate R minus D.
But what are our limits?
What are our limits? Everything starts at 0, so I can put that there.
But it says above 8.
I think it means, yes, it does mean above 8, so W is the time when it happens. So we're going to go up to W, because we want to know how far out do we need to go. And now I understand why I'm not solving this thing. It's
Because they don't want to.
I would have to integrate that by hand in order to put in W.
And then they wouldn't.
Yeah, I don't
Then
want that.
they'd have to do that by hand to
Now,
figure it out.
be careful. This is the amount that is entered. Well, this is the net change in the amount in the pipe from 0 to
You
W.
gotta find out when it's over 50.
Right, but that we can get by just saying when's it greater than or equal to 50. It's 50. Or I guess we should say equal to 50. But this isn't the amount of water in the pipe. That's the change in the amount of water in the pipe.
So we gotta take an interval again?
But it started at 30. There were 30 in there to start with. And it wanted an equation, not an inequality, so we better just put equal 50.
So now that's,
You're done. Like, that's it. It didn't say solve it.
okay.
I know what R is and D is, and that would be it. If you wanted to move the 30 over, or if your brain was just kind of thinking, well, that means it started at 30, it can hold 50, that means this integral has to be equal to 20, then that would have been fine too. Peeking at the time, that took 20 minutes, but we also did some review at the start and some chatting along the way. It also illustrates, I don't remember the point breakdown of this one, but even if you didn't get that last one, hopefully you get the others. Even if you just got the first two, you'd be on your way to making a 3. It also illustrates that to get that last really hard one, it didn't take long. It definitely took some thought, maybe not a lot of time. All right, let's look at number 4. Again, your assignment will be 3 and 5 tonight. We'll go over those, but let's look at number 4. Again, the integral of the rate gives you the change in the amount. That's the key thing to remember on these. On a certain workday, the rate, here we go again, in tons per hour, at which unprocessed gravel arrives at a gravel processing plant. So G of T is 90 plus 45 cosine T squared over 18.
Tons per
Yuck.
hour.
And that is tons per hour. That's the rate gravel arrives. Okay, I don't have to rewrite any of that stuff, but writing it slows me down a little bit, forces me to think a little bit. T is measured in hours. Oh, we're going 0 to 8 again. I like the 8-hour time frame.
8-hour workday.
At the beginning of the workday, the plant has 500 tons of unprocessed gravel.
When T equals 0.
So when T equals 0, let's make up a variable because we might need it here.
Well, we can't use G.
Don't want to use G. U for unprocessed
Yeah.
gravel? I don't know. So U of 0 equals 500, where U, T equals amount, not rate, but amount of unprocessed gravel. Okay, we've seen this twice in a row where they give you an equation, they give you a point, but the point doesn't really go with the equation.
Yet.
Yeah, yet, because the equation they gave is a rate, the point they gave is an amount. So and they don't explicitly tell you that, so you've got to be careful with that. During the hours of operation, 0 to 8, the plant processes gravel at a constant rate of 100 tons per hour. P of T, processing rate, equals 500.
No, it's 100.
100, sorry. 100 per hour.
Would it be 100x then?
Okay, so be careful. You sort of just integrated on the fly there. So the rate is 100, but the effect of the change of that on the gravel is 100x. You're right. So keep that in mind, or 100t. But the rate itself is 100 tons per hour. Okay, so we've spent like 3 minutes interpreting the problem before we even get to.
Because that's you're explaining it to us.
No, but even that's just to say, even when you get these problems, you're going to spend a couple minutes reading, processing, thinking, setting up before you even get to a question, like trying to properly understand the problem. Then we'll go read the question, and hopefully it's smooth sailing from there, or at least easier sailing from there. Find G prime at 5. Okay, well that's a gimme point right there with the calculator. I can do that. Using correct units, interpret your answer in the context of the problem. Well, I don't know about that part yet, but I think this is a very similar problem to last time. Right? We got some coming in, we got some going out. So I'm going to call Y1 G. I don't have to say that, but I'm going to, just so I keep it straight, and in case I mess up and call it Y1 later, the grader will cut me some slack since I explained what it is. Alright, I guess I could put Y2 as 100 if we ever need to integrate both of them. I'm going to turn that one off for the graph though, because I don't really want to see that. I just want G prime of 5. Oh, it's not there, but that's because I'm supposed to be up around 90 and 45.
Yeah.
Or, if I don't want to mess with that, I can do math.
8.
It's not 9, but 8.
DDX.
DDX of Y1 at 5. And again, they know you have a calculator. They know that the calculator will do this, so you do not have to find by hand G prime.
But
You could. It would be a sign and then a product rule, not a product rule, a chain rule with a 2t, but I'm not worried about that. The calculator does it, so we're good.
We have to find the units though.
But we need a unit, and then we need a explanation of what that is.
Tons per hour squared? I don't know.
No, you're right. G is tons per hour, and T is hours. So you can leave it as tons per hour per hour. You could say tons per hour squared. Either one would be okay. But I'm still not done.
Yeah.
Using correct units, interpret your answer in the context of the problem.
You shouldn't have squared that.
So 24.588 tons per hour squared
Where'd the negative go?
is the rate. Well, I'm gonna use the negative in my description. I'm gonna say something about decreasing. So what is G? G is the rate it's arriving. So I want the rate of a rate. Is the rate that the rate of gravel arriving G is decreasing. So I know that seems weird, the rate of a rate, but G is a rate, so G prime is the rate of a rate. If you wanted to leave the negative on, you could.
It's changing.
You would just say changing, and that'd be a safe way to do it also. Be careful though, don't put negative in decreasing, because those would sort of counter each other.
Double negative.
Part B, find the total amount of unprocessed gravel that arrives at the plant during the hours of operation on this workday. So, the amount that arrives,
The total amount, that would be the integral of G.
that would be the integral of G,
From 0 to 8.
from 0 to 8. You start to get the hang of these problems, especially when we group them together like this. And you're like, oh, they're kind of all the same, whether it's snow or rain or grass. It's just the same thing. Math 9, 0 to 8. Y1, dx, 825.551 tons. Okay, so be careful. That's how much has arrived.
So what's the total?
Arrives from 0 to 8. Well, let's be careful about what it asks here.
The total amount of unprocessed gravel.
That arrives. So that is the answer. Now you're right. They already had 500 sitting there, and 100 was leaving per every hour. But that's not what it asked. It just said how much arrived. So 825 tons arrived. So yeah, we would need to maybe add 500 and subtract 800 if we want to keep up with everything. Part C is the amount of unprocessed gravel at the plant increasing or decreasing at t equals 5 hours. Show the work that leads to your answer. So we said U is the amount of unprocessed gravel.
And it's just another, like the previous one, R minus D.
So U prime is whatever we picked here. G minus
I put 100 because that's.
Yeah, I don't know that we labeled anything. G minus 100 is fine. Because G is the amount coming in, the rate coming in. 100 is the rate going out. So G minus 100 will be the rate of unprocessed gravel at the plant.
They want to know it at 5.
At 5. So U prime at 5 is G of 5 minus 100. Because the 100 is constant. It's always leaving at 100. So Y1 at 5 minus 100. Negative 1.859 tons per hour. So at that time, more is leaving than is coming in. Increase. Oh, I almost just left that as my answer. So is the amount of unprocessed gravel at the plant increasing or decreasing?
Decreasing.
So U is decreasing. Remember, I already defined U as the amount of unprocessed gravel, so I don't need to say all that in a sentence.
Okay, next one's asking about a maximum.
What is the maximum amount of unprocessed gravel? So the max of U would be where, so ignore all the rest of this problem for now. Where's the max of U? Like, just answer that very generically. Where does U have a max?
At 0? Because that's 500? No.
Just generally speaking, not even for this problem, how do I know where f of x has a maximum?
When it
changes from positive to negative.
When U prime changes from positive to negative. So sometimes it helps to try to step back from the problem, not get so lost in the details of 100s and cosines and 500. Like, they said maximum. I know what maximum means. Maximum is where U prime changes positive to negative. Okay, so now jump back to this problem. U prime, I already have U prime. U prime is G minus 100. So let's graph that and look for where G prime minus 100 changes positive to negative. Let's see. It was a little silly to just put 100 in there, but it's fine. It kind of matched the format of the other if we do it that way. Y1 minus, I could just do Y1 minus 100.
I did too.
Y1 minus Y2, because Y2 is 100. Either way. And I want to know where that changes positive to negative.
Look for the 0.
Uh-oh. Oh, there it is. Okay, so it's a steep graph. I don't see everything, but I don't really need to see everything. I just need to see where that point is.
Yeah.
So second calc 0. My cursor is not on the screen, but I can scroll until it is. Left bound, right bound, guess. At t equals 4.923.
Yay.
I think that was hours.
Yeah.
U prime changes positive to negative. Therefore, U has a max at t equals 4.923.
That took us 10 seconds away from 15 minutes.
Yeah, because I started at 21. So that took right at 15 minutes. And even that, I was trying to go slow, explain, graph, So hopefully you're going a little bit quicker, maybe. Maybe you don't get all of it. But, I mean, you're fighting for every point, but you don't get all of it, that's fine, right? 45%, you got a 3. So hopefully you hit, the goal really, honestly, is if you could get all of 2 of the free response questions, that'd be fantastic. Because then you just collect a few points on the others and you're good. And hopefully there's 1 or 2 that you're I got this. I understand what's going on. Let me answer all of it. Be good. And then the rest of them, you just fight and claw for all the points you can get. And then hope that that's enough. All right, so your assignment today is, what did I say, 2 and 4?
Or no, that was you.
I did 2 and 4.
3 and 5.
You do 3 and 5.
No, we don't. We don't have to do 1 and 6 though.
You do 3 and 5.
No touchy 1 and 6, unless you
And
want
then
to.
on Thursday, I'll go over 3 and 5. And our test will have 2 problems like those, plus 1 velocity acceleration stuff.
The problems that we're doing tonight are the problems that are going to be like 2 ones on the test.
Yes.
I go to Spark.
Yes.
Oh, yeah, I do Spark.
So that's why I rearranged the calendar to make sure we've got lots of examples right before the test. Well, rearrange the test and rearrange the calendar. Make it all sync up.
So, well, this $5